तो हम लोग तो कनेक्ट करेगा ना,
सर व्हाट्सएप ग्रुप में। और भी आप सर रात के बाद आज सुबह इतने सारे फॉर्म भरे तो उनको भी अवॉइड करना पड़ेगा। कर रहा हूँ सर वही।
हमारा काम फाइनल करवाना है।
नहीं वो अगर फाइनल करवाते हैं ना तो ओपन लिंक्स दे देंगे।
नहीं यूजीज और वो पीजीज का तो कर रहा है कबीर, फैकल्टीज और प्राइवेट प्रैक्टिशनर्स जो किए हैं यही वाला मैं यहीं से लिंक शेयर कर दूंगा बस, है ना?
कॉपी कर लीजिए।
हाँ म्यूट
रिकॉर्ड हुए।
हाँ 20 मिनट लेट आएगा ना, इधर 20 सेकंड लेट आएगा, ठीक है ना? इतना कॉपी कॉपी और कॉपी, ठीक है चल, थैंक यू सो मच।
तो तेरा आसन यही है क्या?
है
तेरा आसन
आज मेरा आसन यही।
हाँ वो वाइट बैकग्राउंड है सर में।
हम तमिलनाडु में
है
अच्छा अभी लिखिए सिर्फ मैं यही लगा ना, हाँ यही लगा लो। वो उसको भी क्या बोलते हैं,
तू जैसा बोल।
नहीं लगाओ ना, वो उससे सरस्वती वंदना भी नहीं कराने बोली में।
हाँ तो उसको ये माइक पहनाना पड़ेगा फिर, इसमें ज्यादा बेटर है। देख लेंगे ऑन द स्पॉट कैसे करेंगे अपन।
मैं उसको बोली है नहीं बोली।
तू पहले एक बार अपन क्लियर कर ले क्या करना है वहां पर, फिर कोऑर्डिनेशन
वो तो होना है आपस में, है ना? और अपना जो गंदमत है यही पहन के आने वाला भाई, देख रहा था ये पहनो या ब्लू पहनो भाई, मैंने चलो ये देख रहा है ये पहनो।
मैं व्हाट्सएप कॉल कर दूंगा, मैं पहले 10 बजे की तो फिर लिंक नहीं, ये काम पहले कर देता हूँ।
लिंक होगी जल्दी।
हाँ सर लिंक तो जनरेटेड है, बट कल रात के और सुबह जो लोग रजिस्टर के उनको ऐड करना बचा है।
साथ में कभी तो रखे, हाँ बाई चांस उसमें बाद में और भी होते हैं तो कभी बीच में ऐड कर जाएगा, लिंक ऐड करेगा और लिंक एक बार फिर से भेज कर जाएगा तो उनको पुराना लिंक दिखेगा नहीं।
हाँ सर
स्टूडेंट्स कितना हो गए? स्टूडेंट सेंटर यूट्यूब से भी, यूट्यूब में तो होगा नहीं, अभी चलेगा 20 के ग्रुप में। ये जो अभी जो फाइनल ईयर है जिसने एग्जाम दिया है उनको बोल दो जो एटलीस्ट लॉगिन तो कर लें। उनको बोल दिया ग्रुप में डाल दिए।
कल वो तेजा को भी बोली थी मैंने, उसको दे दे।
उनके सीआर से बोल दो फोन करके क्या बोलते हैं सभी लॉगिन करने हैं। मैं तो बच्चे 2 दिन से मैं बच्चे से परेशान, मतलब स्कूल वालों से परेशान।
क्यों सर? क्यों?
अब छोटा सा नर्सरी का बच्चा, हमने साल भर तो कभी वो जो आते थे वो एक्स्ट्रा करिकुलर तो करवाया नहीं, जो होमवर्क का ऐसा करिकुलर भेज देते थे। अब इवैल्यूएशन टेस्ट स्टार्ट हो गया, गाना गाओ पोयम बताओ, छोटा बच्चा कितना बोले, अब बोल के वीडियो रिकॉर्डिंग कर रहे दिन भर यही चल रहा है। बच्चे को डांट रहे हैं, बेचारा कितना एक दिन में कितना सीख ले।
आपको भी एग्जाम वाली फील आ रही है इसमें?
अरे जितने बच्चे मैं राजदीप भी परेशान है, बोलता घर जाता हूँ तो मैं चुपचाप रहता हूँ, जो बोलते हैं चुपचाप कर देता हूँ क्योंकि ऑलरेडी घर में सब फ्रस्ट्रेटेड बैठे रहते हैं।
फिर मैम को बोल दो दोनों का नाम ले देंगे शुरुआत में, दोनों स्पीकर्स का इंट्रोड्यूस पहले बाद में कर देंगे।
हाँ दोनों का नाम करने लिए ज्यादा अच्छा है।
हाँ आगे कोई नाम को
इनको बुला लेना पीजी को ये ऐड करते हैं।
हाँ सर बस ये एक बार कर दो, कर ही दिया वीडियो में।
किसका करना है
बच्चे हैं बस।
नाम तो दे रही हो
बोल दे मैम कोई वाला ई जनरल वर्चुअल वाला उसी को लगा देंगे।
नहीं तो सर्टिफिकेट की पीपीटी को
हाँ वो दूंगा, हाँ वो दूंगा।
वो उसी टाइम चेंज कर लेंगे तो पहले तो ये कर ले।
वो तो जो वो बाद में है ना आखिरी में।
हाँ शाबाश की बात नहीं कर सकते।
सिद्धार्थ सुरा नहीं है और सिद्धार्थ सुरा नहीं करो। सिद्धार्थ सुरा ऋतिका पाए तो दोनों के आगे वो है ना स्टूडेंट्स। हाँ
1658 WhatsApp नंबर है ना?
हाँ क्या पता जो भी ये तो ऑलरेडी पीजी है, पीजी फ्रेंड लिखना चाहिए। नहीं तो प्राइवेट प्रैक्टिशनर का लिखना है।
मैम वहाँ पे रहेगी। मुझे ना ऊंची वाली वो चाहिए अच्छी है। ऊंची वाली चेयर कहाँ से है? नहीं प्रशांत के ऊपर मॉरल सपोर्ट करने में। दीदी कौन चाय पिएगा? एनीवन? मैडम को दो तो फिर मेरे लिए ला। वो दोनों चॉकलेट में को थोड़ा और ऊंचा बैठना है। वो नीचे से ऊपर करो लीवर उसका। I'm ready.
सर्टिफिकेट
हाँ सर हो जाए। हाँ मैं तो तैयार हूँ, मैं तो दे भी सकती हूँ।
टाइम क्या हो गया?
तो उसमें एक ही कॉन्टैक्ट में आते हैं।
हाँ
एक ही कॉन्टैक्ट में सब क्या आते हैं?
क्यों?
मतलब इजी सा है ना अपने एक आंसर से
ऐड करने के लिए। अरे बाद में मेरे भी तो कॉन्टैक्ट रहेगा, मेरे भी तो काम आएगा, अलग अलग करने के ना।
उसको थोड़ी पता है कि तेरे का तेरे को उसको थोड़ी पता है तेरे को क्यों चाहिए।
हाँ।
और तो हमको पता है। हाँ बेचारा बच्चा तो तेरे लिए हेल्प करे, तेरे की काम इजी हो जाए सर का।
अरे वही बता रहा ना कि बात का भी सोच लेता। हो गया काम, अब कोई होगा छूट गया तो छूट गया, वैसे ही बोलते हैं, वैसे ही करता हूँ। यहाँ लिख देता हूँ
नोट करके ऐसा। आज चाय नाश्ते का इंतजाम
इसको म्यूट नहीं की, जो ओएस में क्या बोलते हैं फॉलो कर रहा होगा यूट्यूब पे, वो तो देख ही रहा होगा हमको। एक मिनट सर, इसका यूज इस पे कर लो। हाँ हाँ कर ले हाँ, वो लैपटॉप तेरा है।
कोई रखना क्योंकि ओवरऑल तो कोई रहेगा।
मुझे ये लगे अच्छा है भाई।
Call away.
Good morning. Good morning. Good morning.
चालू नहीं हुआ
होता है
क्या
क्या? कैसे होता है क्या काउंट?
नहीं तो छोड़ ना, मैं जीपे में आऊंगा तो जीपे में देना होगा।
जीपे डाउनलोड क्यों नहीं कर?
करूंगा ना, चल
कितना टाइम लग रहा है डाउनलोड करने?
टाइम नहीं मिला, कर लूंगा मैं बाद में, तुमको जीपे दे देना। चालू नहीं हुआ है क्या?
ये बैनर हमेशा आता है। क्या क्वेश्चन है?
A very good morning, all of you.
Sherry.
A very good morning, all of you.
पूरा chapter
And I welcome you all from the Department of Prosthodontics, Chhattisgarh Dental College and Research Institute. Firstly, I would like to request all those whose mics are on, kindly mute them. So we can enjoy this program without any glitch smoothly. I request all of you to mute your mics. Okay, let us start. A very good morning again. We, the Department of Prosthodontics, welcome you all to the live. Again, I would request all the staff, students, to mute your mic. Okay, well, that being done, a very good morning again. And we, the Department of Prosthodontics, Chhattisgarh Dental College and Research Institute, welcome you all to our live webinar on CAD-CAM, a step towards digital prosthodontics. I, Dr. Rucha Kashyap, Reader, Department of Prosthodontics, with immense honor and privilege, welcome you all once again. I welcome our Honorable President, Mr. N.C. Parekh, sir. I welcome our Honorable Vice President, Sudhir Bodhan, sir. I welcome Mr. Sanjay Golcha, sir, Secretary, Chhattisgarh Dental College and Research Institute. I welcome Dr. Hema Surivanshi, ma'am, Dean, Chhattisgarh Dental College and Research Institute. I also welcome our keynote speakers, Dr. Satyam Vankere and Dr. Yogesh Ingole. I welcome all the staff and student delegates and the attendees of this program. Our organizing chairman of this event, Dr. Shalin Sahu, sir, professor and head of the department, Chhattisgarh Dental College. Our organizing secretary, Dr. Anurag Dani, professor, Chhattisgarh Dental College, and the entire organizing committee. We are in the world of digitalization. Digitalization of healthcare and thereafter dentistry has transformed the way the dentist and the patient interact. The chief areas where you must all have seen dental digitalization available are CAD-CAM, caries diagnosis, implant dentistry, digital radiography, lasers, occlusion, TMJ analysis and diagnosis, be it intraoral and extraoral, and also, but not least, practice management, patient record management, patient education, and henceforth. But the most common thought of digitalization is, and of course, the stepping stone of digitalization in dentistry has been computer-aided designing and computer-aided manufacturing. So let us explore this area in detail today. So like any other program, let us now take the blessings from Goddess Saraswati, the goddess of knowledge, wisdom, music, and nature, for the free flow of wisdom and consciousness to make this program a success. Please begin the Saraswati Vandana. Over to you, Asha.
Ya kunde har davla ya shubhr vastramrita ya veena dand vandit kara ya shvet padmasana ya brahma chut shankara prabhiti ve निःशेषजाड्यपः निःशेषजाड्यपः निःशेषजाड्यपः.
With that, blessings, now I request Dr. Shalin Sahu sir, head of the department of our department, to give us the welcome address. Please, sir. Over to you, sir.
Good morning, honorable members of Board of Directors, respected Dean Ma'am, Dr. Hema Suryavanshi, respected guest speakers, Dr. Satyam Wankhede, Dr. Yogesh Ingole, heads of the department, senior faculty members, my colleagues, delegates, and dear students. Great things happen when there is a gathering of great minds. It is with great anticipation that I welcome all of you to this webinar, CAD/CAM, a step towards digital prosthodontics. We are honored to have Dr. Satyam Wankhede and Dr. Yogesh Ingole. Both of them are esteemed academician and clinician par excellence. I welcome you, sir. Ladies and gentlemen, dentists are probably most likely to suffer from cross-infection. Keeping this in mind, and also as we are entering the digital era, the theme of this webinar, CAD/CAM, a step towards digital prosthodontics, is timely and appropriate. The application of CAD/CAM system is promising. Though casting procedure has advanced over the past years, each of its steps may lead to the error. There is no doubt the application of CAD/CAM technology in dentistry will provide innovative and state-of-the-art dental service. The purpose of this webinar is to give an in-depth knowledge of CAD/CAM technology as today's dentistry has entered into the digital era. Despite the sharp growth observed in CAD/CAM, the number of dentists using it remains low. I sincerely hope upon the completion of the program, more dentists will be encouraged to embrace digital dentistry. I'll conclude by quoting Albert Einstein, who once said, "Wisdom is not the product of schooling, but of the lifelong attempt to acquire it." With these words, I welcome you again and hope you all have a wonderful session. Thank you.
Request Dean, Chhattisgarh Dental College and Research Institute, Dr. Hema Suryavanshi ma'am, to say a few words for this program. Kindly, ma'am.
Respected Board of Directors, then today's guest speakers, Dr. Satyam Wankhede and Dr. Yogesh Ingole, all our faculty members and the organizing team. I welcome you all for this program. I thank Dr. Satyam Wankhede and Dr. Yogesh Ingole for accepting our invitation and for being ready to deliver their speech and share their knowledge with our team. I hope this CAD/CAM webinar arranged by our Prostho department will be of great help, will be of immense knowledge for our postgraduate students and our faculties too, and not only of Prostho department but of the whole college. I also congratulate Dr. Satyam Wankhede and Dr. Yogesh Ingole for having CAD/CAM in Dr. I am I am proud to be a teacher of Dr. Yogesh Ingole, and
Sorry for the, I think there's a little glitch in the network, but with wholeheartedly, I thank Dean Ma'am for those kind words. We will wait few minutes and some time for Ma'am to reconnect. Yes, Ma'am is with us again.
it's okay, fine, it's okay.
Thank you, Ma'am, for those kind words.
So, Yogesh Ingole,
Thank you very much, ma'am.
Dr. Satyam,
Thank
am
you,
I
ma'am.
audible?
Yes, ma'am.
You are audible. You are audible.
Yes, yes. Thank you for accepting our invitation
Thank
and
you,
joining
ma'am.
this web.
It's our honor. It's our honor. We are very much thankful. Thank you, ma'am.
Thank you, ma'am. It is my privilege to have you as a teacher. Thank you very much, ma'am.
Chalo, welcome, welcome. Over to you, Dr. Rucha.
Thank you so much, ma'am. Thank you for those kind words and those encouraging words. Now let me take a few minutes to introduce to all of you. I would like to introduce today our keynote speaker. Number one, our first speaker, Dr. Satyam Wankhede. Dr. Satyam Wankhede is MDS Prosthodontics, and he is currently working as an associate professor, Government Dental College and Hospital, Nagpur. He is a postgraduate teacher and has an experience of more than 14 years. Sir has been working on CAD/CAM since last 5 years. He has been working on various research projects and thesis work with postgraduate students related to CAD/CAM. Sir has, to his credit, 28 national and international publications, also a monograph published on articulators by the Lambert Publication, Germany. The department at GDC Nagpur is a well-equipped department with dental CAD/CAM. Sir says that in today's world, CAD/CAM
खतरनाक मार पे
single crown to multiple various bridges to implants to milling of bars for hybrid prosthesis and even for full mouth rehabilitation. In his department, more than 4,000 plus prostheses are fabricated annually, and he says that a single crown can be developed in an hour. We welcome you, sir. Over to you, Dr. Satyam. Please start with the webinar.
Thanks. Am I audible?
Yes, sir, you are.
Okay, thank you. A very good morning to all of you, respected Dean Madam, Dr. Suryavanshi, today's organizing chairman, Dr. Shailendra Sausar, professor and head department of prosthodontics, my own friend, Dr. Anurag Dani, and all the organizing committee members. I welcome you all for the first ever webinar on CAD/CAM, the step towards a digital prosthodontics. Right. So let me share my screen first. You are able to see my screen?
Yes, sir.
Yes. Okay, fine. So this is the institute where I worked since last 14 years. It's Government Dental College and Hospital, Nagpur. And we had an individual CAD/CAM center and a department wherein it was established way back in 2017, right? Wherein various prostheses along with workshops as well as seminars we organize, and we carry out the hands-on for the various participants. So before we begin, I'll just ask you one question. You are all ready for it? So So it was way back last year in my presentation. I just asked which are the most pleasing 5-letter words, and so one-to-one interaction is not possible. So most of the delegates they said that money is the most pleasing 5-letter words. Of course, money is, but when you pay the income tax, it seems to be an unpleasing one, right? So yes, and someone uttered it's smile. And someone uttered, yeah, it's a smile. Yeah, smile, it increases your face value. How many of you smile? Of course, we all smile, right? And we, the dentist, and especially the prosthodontics, play a very important role to enhance one's smile. And therefore, this presentation will give a more aesthetic restoration and to increase the face value of one's with the help of CAD/CAM dentistry along with digital impression. For the next 45 to 1 hours, I'll be speaking on various aspects of CAD/CAM dentistry along with digital impression making. Now, to begin with, the journey of the successful prosthesis, it starts with the perfect impression, right? And with the perfect impression, you get a perfect prosthesis along with the perfect line angles as well as the margins, extension of the restoration, which give you a proper contour of your restoration. And this change in the technology as well as the truly revolutionizing changes what is being taking place in dentistry, with the advent of the CAD/CAM, it has enabled both the dentist as well as the laboratory and to design various aesthetic and durable restorations. The flexibility, speed, precision, and efficiency of all these restorations has made to use CAD/CAM in wide range of its application. Now, before beginning, let us have a comparison between a conventional impression and a digital impression. In cases of when you make a conventional impression, that is, you take a stock tray or a customized tray, you make the impression with either alginate or your silicon body base. You cut the excess, you disinfect it, pour the cast. After pouring of the cast, you retrieve it, go for your die etching as well as die cutting. Followed by that, you go for fabrication of wax pattern, investment, then you go for burnout, then you go for casting, retrieval of your casting, cleaning it and trying it onto the cast, and then finishing it, then going for layering. So, and then you go for layering, and then you get a finished prosthesis or a finished prosthesis on a model, right? So it takes days together to fabricate a restoration, right? However, in case of a digital impression, we use the optical scanners that are nothing but the intraoral scanners. We scan the image. After we scan the image, the data which we receive, we transfer it into a computer software in which we do go for designing of the prosthesis, and later on we go for milling, and that's it. So hardly believe me that it takes hardly 45 to 1 hour for a single glass ceramic crown to fabricate. So that much time is been very with a very short duration, you are able to fabricate a prosthesis. However, there are problems that are associated with the conventional technique. Initial, you mix the material, you take the impression with the stock tray. There might be tendency of gagging with the patient, or there might be a bond failure of the impression when you retrieve the material is being set and you retrieve the impression tray from the patient's mouth. There might be a breakage in the bond between the tray and the impression material, or the patient might have a limited mouth opening. If at all you have gained of making the impression, there is no gagging, it has a good bond strength with the impression material, and you are able to retrieve a good impression. But again, you need to pour the cast, wherein there are chances of discrepancy in the cast due to entrapment of air bubbles, right? So after gaining or pouring of the cast and retrieving it, then we go for the laboratory procedures. Now, again, that is a tedious. Earlier, I told you that we go for the laboratory burnout, the casting procedure. It may add to error. Also, the casting errors do play a very a role in your final prosthesis. right? So to overcome all these factors, we are here with computer-aided designing and computer-aided machining. These are broadly divided into three components, that is the scanners, which is the first component and which plays a very important role. We have broadly divided into the optical scanner and the mechanical scanner. Once you capture the image with the help of the scanner, you design it with the help of a design software. Now, once the prosthesis is being designed, then it goes for processing with the help of milling unit. Now, the optical scanners or the scanners, they are supposed to be the eagle eye in dentistry, and you scan your way to redefine its precision. Broadly, the scanners, they are divided into intraoral scanners and extraoral scanners. So intraoral scanners, we scan the impression or we scan the source intraorally, where in case of extraoral scanner, either a cast or an impression is being scanned, especially in the laboratory. Our lab is well equipped both with intraoral as well as extraoral scanners. And these scanners, they help in collection of the data, measure the three-dimensional jaws and tooth structure, and transfer this digital data set into the software. Way back in 1971, it was Dr. Francos Duret who developed the first CAD cam, and he fabricated the crown with an optical impression of the abutment, followed by designing and milling. Later, the CERAC system, which was developed by Dr. Morman, and Procera system was developed by Dr. Anderson. So the digital scanners, they are in aid of teaching for the patient, both for the patient as well as for the students also. You scan the image, you stand in front of the patient or a suitable position where you can scan the object. Now the sources or the scanner is placed in such a way that it is 45 to 60 degree angle to the object. Now you hold it in the patient's mouth and you scan accordingly. So here we get the images of the objects, and you are able to scan with the help of an intraoral scanner. So the intraoral scanners, they are used to create a digital image of the patient's teeth. No need of impression, that is impression materials, they are eliminated. A videographic image is being acquired, and a digital, with the help of a digital scanning device, and the patient's dentition along with the bite relation is optically recorded. Now, this is recorded with the help of a light that is projected from the tip of the scanner, and the camera, it collects the data. Now, this data, it can be manipulated, and with the help of it produces a digital model of the patient's dentition. So you are able to manipulate the digital data. You can do all the changes what you want as per your convenience, and the software will also help you to give you the final outcome in the prosthesis, right? However, there are recent advances. We have the CEREC OmniCam and CEREC BlueCam. So research still are going on, wherein in case of CEREC OmniCam, this scanner takes hardly around about 45 to 60 seconds to record the whole arch, right? As well as the working end, that is the probe of the camera is so sleek that you are able to record the most distal part of the tooth surfaces as well as the undercut areas. So intraoral scanners, you scan the tissues, you get the data with a three-dimensional unit. From that, you transfer it to the computer software, you do the mapping. In the mapping, with the help of a software, you design the restoration, and once you design it, you go for milling and you get the final restoration. So here is, you scan intraorally, you scan, that is the images of 1.1 and 1.2. So you design the restoration in the software, then you go for processing. Now, either of the material, whether you want to use a glass ceramic or infiltrate ceramic or your lithium disilicate blocks, or you can use zirconium dioxide. So you can use it once these blocks are being adjusted into the material, it is called as the nesting procedure. And after nesting, you go for milling of the restoration with the help of your milling machine. Now, this is the final restorations with 1-1 and 1-2. Believe me, hardly it took around about 1 to 1.5 hours to give the prosthesis to this patient, right? So all the scanners which are available in the market, they work on certain principles, right? So broadly, they work on confocal laser scanning. Now, this scanning principles are of interest for mostly for the postgraduates, because in our university, they ask a question or an essay on recent advances or CAD/CAM in dentistry. So I think postgraduate will be much more helpful. Now, these scanning principles, they depend upon the various aspects, that is the confocal laser scanning microscopy, then the triangulation technique, the accordion fridge interferometry, then the optical coherent tomography, and active wavefront sampling. In case of confocal laser scanning microscopy, a beam of light passes through an aperture and it is focused on the objective lens. Now, these light which are focused on the objective lens get scattered and reflect. The laser light it gets reflected and it's recollected by the objective lens. Now, once it gets recollected, it forms an image, right? It forms an image. Now, these continuous forming of the image, they are stitched together to give a broader image. Now, this is the principle that it is called as a stitching principle. So you get multiple amount of images and they stitch together. Now, these are basically designed, the scanners that are the iTero, then 3D Progress, the Trios, and the CS3500. They work on the confocal or the parallel confocal imaging technique. Now, the basic advantage of this confocal scanner microscopy imaging is that you get more exact and precise image because it works on stitching principle. So the depth the depth of the image is very well captured in cases of the stitching principles. The second is the triangulation technique, wherein it depends upon the Pythagoras theorem, wherein the laser dot, the laser emitter, and the camera, they form a triangle to capture an image. The various cameras that are the CIRAC, that is the iOS fast scan, then the direct blue scan and the blue scan, they work on triangulation technique. Then accordion fridge interferometry, wherein two laser lights, they illuminate the object and create an interference bridge pattern. Now, as a high precision digital camera will record this fridge curvature and will form an image. Now, the true definition scanner and the DPI of 3D, they work on accordion fridge interferometry. The optical coherent tomography, in which the subsurfaces as well as the microstructures of the target object and like the biological tissues, they are very well captured. The best example is of E4D, which is designed by D4D Technologies. The active wavefront sampling, that is in this a single camera, and the active wavefront sampling module, which is of an off-axis aperture, and it moves to a circular part along an optical axis. So one optical part to capture whole of the depth information. So the best example of active wavefront sampling is the lava chairside intraoral scanners. Now, all these cameras, which works on various scanning principles, they are broadly either of open or a closed architecture. Now, open architecture are the files that are typically in the standard transformation language, that is the STL files, which are not dependent on the manufacturer, and they can be used virtually in any design software to fabricate a final restoration. For example, if you have a scanner of XYZ company, right? So the company in itself will have their own design software. But in cases of an open architecture files, you can transfer it to any of the software available with you or any of the other company's software. So that is an open architecture file, wherein if you are not able to use other software of the other company, then the data which or the soft or the data which you collect from the scanner is not been manipulated by the other software design, then it is a closed system type or a closed architecture. So closed architecture softwares are the architect are collects the and manipulates the data module by the same manufacturer, and no other manufacturer can interfere in their system. This is something a proprietary type, so you cannot interfere in or designing cannot be done in in the another software. So salient features before you go for any purchase of any of the scanner in the market, you should be able to see for the trueness, precision, resolution, then whether you need an optimization or the scanning speed, then tip how it is, image how it is formed, and the systems. So trueness and precision, it should be high. Now, how do you calculate this trueness and precision? In trueness, you calculate it that when one of the specimen that is to be scanned with a single scanner, initially this specimen is being placed on the scanning table, right? It is scanned. Then the object which is scanned is removed from the scanning table, and again it is refixed onto the table, and again a scanning is being done. So you scan multiple amount of scans by removing the object from the scanning table, right? By removing the object from the scanning table, this will give you the value of the trueness, right? Wherein case a precision is once a specimen is being scanned several times by a single scanner without being removed from the scanning table. So multiple images without removing the object from the scanner, that will give you the precision. So trueness and precision are of a very prime importance when you purchase any of the scanners. Lower the trueness and precision, greater is the accuracy of any of the cameras. Resolution, of course, it should be high. Whether now in the market, all the cameras what are available or the intraoral scanners what are available, they are powderless. So you did not to spray powder to capture the image. Earlier, the scanners of the older version, you need to spray the powders that is basically consist of barium so as to capture the image, right? Scanning speed up, of course, it should be fast. Then tips, it should be small so as to record the most distal parts of the tooth surfaces as well as the undercut areas, that is the proximal surfaces, prepared proximal surfaces. You must be able to record it, as well as you should be able you should have a colored image, and the system, it should be open. So these are the salient features when you go for any of the camera to purchase. Now, basically the trueness and the precision values of various commonly used intraoral scanners which are available in the market. So of these, the Trios is supposed to be the best, which has the trueness value of 6.9 microns and a precision of about 4.5 microns. What intraoral scanner we are having is CS3500, in which the trueness value is 9.8 microns and precision of 7.2 microns, same as that of iTeros. So iTero, CS3500 and Trios. Now CS3500, a newer version, is also available of Carestream, which is 3600. So broadly, these intraoral scanners, they are open-ended. There are some exceptions such as E4D, which is a closed system one, and a Lava, as well as the Sirac one, Sirona, which is again a closed system one. Then they work on various principles, already I have discussed it. Then the light source, various companies, they have different light source, that is blue or green or the laser light. All these are form of a illuminating device which helps you to capture the image. Now, images, they are captured in a photographic form or in a videographic form. That is, I already spoke you in cases of a photographic, it works on the stitching principle. There are the cameras, what are available. There are hardly any camera left which needs coating. So all of them, they do not need any coating. That is spraying of any material to capture the image. Then the images that are formed all are colored in office milling. It's available with KSTM as well as the Sirona, Plan Mica, and the 3M. They do not have, and 3Shape also do not have. So in office milling, these companies, they do not have, wherein all of them mostly they have, they capture the data in the STL format, that is the standard transformation language format, wherein others, they do have the proprietary items, that is a closed architecture, that is the Trios and the Sirac of the Sirona. So broadly, the advantages and disadvantages milling, whether it's in-house milling or it takes longer duration to scan. Some cameras wherein the camera which are available with us, that is the CIREC 3500, takes longer duration as it works on a stitching principle. So likewise, the newer version of KSTM, I told you that CS 3600, it captures a videographic image and it takes lesser duration of time. Some do require coatings such as the E4D, it requires coating to capture the image. So overall, the benefits of digital impression, it helps in accuracy of impression, then opportunity to view, adjust, and rescan the impression. Now, once if you are unable to capture any of the part of the tooth structure, right? So you, instead of rescanning the whole of the arch, you can scan that particular area. So that rescanning of the impression or the arch, that adjustment is available. You do not need to have any physical impression of the patient. It's really time saving and one visit for in-office system, in-house milling. Then opportunity to view the occlusion is there in the software. You can view it from all the aspects. You can view your preparation. If you need any correction in your preparation, you can do the modifications accordingly. So accurate restorations can be fabricated with the help of the digital model, and potential for cost sharing machine. Now, cost sharing, that is, if in a group, if you try to purchase it, it will help in cross sharing of the machine, as well as it will be beneficial for the society, and it will be add the money to your pockets also. So it prevents the wear and chipping of the porcelains, which is most commonly in cases of your custom conventional fabrication of all ceramic or your metal ceramic prosthesis. No layering or baking is required. Layering is required when you are fabricating bridges bridges with a coping in CAD/CAM, right? Wherein in cases of a single crown or in cases where you are fabricating it with a zirconium dioxide 3-layer complete bridges, there you do not require any layering, just you go for stain and glaze and it's done. No casting procedure or soldering procedure. So long unit bridges, there is no need for soldering, as with the software you can determine a single path of insertion and removal. So there are no multiple paths and you can easily insert the prosthesis in the patient's mouth. No chances of cross infection, and in cross infection and patient is much more comfortable. However, there are certain disadvantages, but that is the expensive. I told you that if you share it, so it's very easy. The expensive part, it gets reduced. Wherein the digital equipments, they are complex and trained operator is required to operate and maintain the device. Again, this, as our generation, we are living in a digital world, and 2-3 functions in our mobile phone also, if it get increased, so we try to shift on our phones, right? So same is that when you go for a digital or use a digital equipment, once you are used to with the software, you can rightly use it. And once you are used to it, you can clearly with no grudge, you can handle it properly. Then good up-to-date laboratory support just for your staining and glazing, or in cases where you go for your layering purpose, where you have fabricated a CAD/CAM copings, in that cases you require the layering purpose. Other than that, the staining and glazing you can do of your own only. Then those with patients with having small mouth and difficulty in opening the mouth. So again, with the recent advances, that is with the sleek working probe of your intraoral scanners, it is very easy where the patient is having a limited mouth opening, you are able to capture the image. So I think the disadvantage has overcome to the advantages, and there are very less disadvantages as compared to the advantages what we have seen. So these are, so in the prosthodontics, you can go for fabrication of resin, inlays, onlays. You can go for fixed prosthesis, multiple unit bridges, zirconia copings. Then you can go for single unit lithium disilicate, then fixed prosthesis, 4 to 5 units zirconia. Then you can go for implant bridges and implant supported bars attachment, overdenture bars. You can go for fabrication of your cast partial dentures, that digital smile designing, obturator, as well as it's a very good teaching aid, both for your patient as well as for the postgraduates and the graduates. You can go for complete denture prosthesis. So now I think no prosthesis is being left in Prosto to be fabricated with the CAD/CAM prosthesis. Then in implantology, it helps in guided implant surgeries for your designing of your guides. It helps a lot. So in cases of orthodontics, that is diagnosis and treatment planning, then designing of aligners and custom-made devices, as well as a virtual patient you can have. So after you get the data with your intraoral scanner, you transfer this data in which you get basically in the form of a STL format. You transfer it into a design software. Now, design the softwares they help in to design the prosthesis, right? The softwares which are available in the market, they are continuously you see a number of functions going on, newer functions being added in the software. So basic software which is available and most commercially used is the ExoCAD. The data of the construction, it can be stored in various data formats, and basic data format is the standard transformation language, that is the STL data. And manufacturers, however, they have their own data formats, which is again, I already told you that it is a form of a closed system architecture. Now, once you transfer the data into a computer software, the image you can move both in a 3D image as well as you can have a 2D view of whole of the arch as well as the opposing quadrant. Now in the software, I'll now quickly show you how the stepwise the designing, because in detail it will be covered by my friend Dr. Yogesh to how you go on stepwise designing of the prosthesis. Initially on the screen, when you just open the software, you get this form of the screen in which you add the client, that is the person working, the name of the patient and the technician. Here we are both the client as well as the technician. As we are in the government institute, we do not have that much amount of trained technician, and therefore we have a dual role, both of making for the preparation also, scanning also, and doing the layering and the stain glaze procedure, right? So it's all about our college. So in the software, then we have the job definition where you can see the tooth marking accordingly, your Palmer notation, that is from 11 to 18, then 21 to 28. So all the tooth that have been marked. So accordingly, what restoration you want to fabricate, which tooth are missing, where you want to give a Pontic, where you want to give a complete anatomic crown, where you want to give a coping, the antagonist teeth, all are color coded, and the color codings will give you what type of restoration or what type of prosthesis you are fabricating. Whether the green color will show you the coping, the brown color will show you the reduced Pontic, or the adjacent teeth in yellow color as well as the purple color, the antagonist. So on the extreme right of the software, you can perform various actions. That is, you click on the software, will start to function. In cases of Ceramil map, wherein an extraoral scanner, where if at all you are having a cast or an impression, so with the help of Ceramil map, you can manipulate or capture the cast image or the impression image. In cases of Ceramil mind, where you design a prosthesis, in Ceramil Match 2, in Ceramil Match 2, you go for a matching of the prosthesis, what type of material you are using. You place the prosthesis in that material, either it might be in the block form or a disc form. And once your prosthesis been matched in the material what you have selected, you proceed for the milling purpose. Now milling is done with the help of Ceramil Motion software, right? So these are the various actions that are being performed by the software. Now, once you transfer the image into the software, then this image, what you get, both the prepared one and the unprepared, that is the opposing arch also you will get. And after that, you go for marginal detection and drawing of your margins of your restoration, right? So you are able to locate the margins. It will automatically, the software in itself will automatically locate it, or you can manipulate it accordingly. So wherein you see that you need to move the margins, so you can move manually with the help of the functions being available. So you draw the margin. So already 1-3 margin has been placed, and it will give you the tooth number also accordingly. After you have finished with the margin placement, then the software in itself, depending upon the various size and forms of the tooth available, of the image of the tooth available in the image, it will give it from the library itself. Or if you want a different image or different size, shape, form of the teeth, you can select it from the library, right? So library is being available in the software, and once the teeth has been selected, so you can move it accordingly. You can move anteriorly, posteriorly. You can give the rotational movement to the tooth surfaces. Even you can go for marking of your mamelons. You can place the grooves. You can increase the thickness of your material, as well as you can move the entire tooth. You can mark the ridges, as well as, so all the minute movements required, you can perform it. You can add on the material if you want more amount of thickness to your restorations. So this you can do by freeing or free forming the image. Now the next is you go for the proximal correction and redefining of the of your restoration. Now what amount of proximal contact is being present, or if you want to increase the amount of the thickness, it will give you in millimeters, right? Or the contact of your Pontic with the tissue surface, the amount of the contact with the tissue surface, again it is markedly and accurately been measured. So if you are going for a modified wrist lap Pontic, how much amount of contact you require on the gingival aspect, or if at all you need a sanitary pontic. Now the distance from the tissue surface to the pontic area, that distance also can be calculated. So accurate you have. So in the software you can do miracle things, right? So once your restoration is being done, it is smoothened and fine corrections being done. So it is smoothened and you are ready for the prosthesis to go to the next level software. Now in this case, as we are fabricating a long span bridges and an anterior one, posterior, if it could have been, we could have been fabricated in zirconium dioxide, that is a sintered one material that is available in a solid, that is ceramyl solid form. But as it is anterior bridge, we are fabricating a coping one with the help of a 3D image. So the final copings that we get are this, and the software in itself will shrink to give you the final copings. Now these copings are to be attached with the help of the connectors. Now if you proceed in the software, it will give you the connectors in position. Now these connectors, they are of various thickness and they are color coded. Now purple will give you the most thin connector, and the thickest one is the dark blue. Now if at all you want to increase the amount of the thickness of the connectors, you can increase it. Now it depends upon what type of the patient. If the patient in itself is a heavy chewer, then you need, and what much amount of occlusal forces is being acting onto the prosthesis. So accordingly you can increase the amount of the thickness. You do not increase the amount of the thickness so much that it will compromise your aesthetics, right? So in cases of anterior, you can go for increase of the thickness of the connector palatally, as it is not visualized, and it will add strength to the prosthesis, right? So I have increased here the amount of the thickness. You can very well appreciate that the purple is being changed to greenish and bluish one, and thus we have increased the amount of the thickness of the connector, mostly from the palatal aspect, right? So this is the final design, and it is ready for a nesting of the restoration. Now in the nesting, you select the material, what material you want to be fabricated in. Here we are fabricating in zirconium oxide material. So these are the pre-sintered one. Now zirconia discs, they are available. Zirconia in itself is in the powdered form. Now they are a little bit sintered to form a blank, right? So a disc form, right? It is not completely sintered, because once if it gets sintered, it becomes rock hard. So it is a pre-sintered one, taking into consideration the durability of the burrs which are used for milling. So likewise, we have the various discs available, which is having a 98 diameter this disc, or it may be in a circular form or a semicircular form. So a semicircular will be is having around about 70 mm of diameter. So you select the material and you place it, you place the restoration in it accordingly. So the prosthesis is being nested and the pre-sintered, that is zirconium dioxide disc, and now the various lateral studs, or what you call in your conventional, that are the sprues, which are joined to the to your casting surfaces. Now in cases of CAD/CAM, these connectors, they are laterally connected to the base disc, right? So it will provide the strength to your casting or your prosthesis during milling, right? So you can increase the amount of the thickness of your connectors or decrease it accordingly. Around about 2 to 3 millimeters we keep, and it depends upon how long span the prosthesis you are fabricating. Or else if you want to decrease the number of the sprues also, or the connectors, you can decrease it, as well as you can reduce the thickness. All you can do it. Now, once it has been nested, so in cases of zirconium dioxide, you have the circular blocks. And in cases where you are going for fabricating of single crowns, especially the interior one, where you are using a glass ceramic or lithium disilicate blocks or feldspathic crowns, or single unit, anterior and posteriors. So in that cases, a single unit can be nested in this types of blanks, wherein carbide burr they are being used. And you at a stretch, you can go for fabrication of 3 single crowns, and hardly it takes around about 45 minutes to fabricate a crown, and rest 5-10 minutes for your stain and glaze, right? So this is you have the another system, that is the indirect system, wherein with the help of an intraoral scanner, you directly scan it and transfer the data into the software. If in cases of laboratory, as well as in cases where you are having the subchangeable margins, and with the help of a scanner, if you're not able to record the depth of your preparation, in that cases you are advised to have a impression, right? Elastomeric impression. Now, once you get an impression, you can scan it in the laboratory scanner. We have the Ceramil Map 400, which helps to scan both the cast as well as the impression. You can also have a record the bite. You placing the upper and the lower cast, you can record the bite also of the patient onto the cast. So details will be covered by my friend Dr. Yogesh. We will show you the laboratory scanner also. You can go for fabrication of posterior crowns, wherein the greenish one shows you the tight contacts, so which might be detrimental during the lateral excursive movement. So you can reduce it in your designing part only when you are doing it with your, or manipulating the design with your softwares. Same as you can go for fabrication of inlays, as well as your posterior fixed partial dentures. Now, in cases of long span bridges, you can have establish occlusion, whether you want to go for a group function or a mutually protected. You can design it accordingly. You can go for fabrication of implant prosthesis also, and likewise with if the various mandibular movements can be transferred into the software. Now, you measure the patient's incisal guidance, as well as the condylar guidance, the Bennett shift, and the immediate side shape, transfer it into the values you need to transfer it in the software, and with the help of a virtual articulator, you are able to do various movements. Thus, it will help you to establish occlusion, to form occlusion, whether what type of occlusion, especially in cases of full mouth rehabilitation. We use the virtual articulator. Now, here the software, they have the Bennett angle, the immediate side shift, and the condylar angle. So you insert all the values in the software, and you are able to perform various movements. Just you can markedly seen in the video that you can see various jaw movements that are taking place on the virtual articulator. So all the interferences during both the lateral excursion as well as protrusion, you can the virtual articulator himself, it eliminates all the interferences, and you can establish a nice occlusion with the help of the various movements, jaw movements, with the help of your virtual articulator. Right. Now, once you have done with your final prosthesis and nesting of the prosthesis, then you proceed with milling of of your prosthesis. Then milling is nothing but the processing of your prosthesis, and it is being done with the milling machine. So in cases of your glass ceramics, or where you are going for fabrication of your single units, in that cases you are with the sintered blocks, right? So in case of sintered blocks, you can fabricate a single unit crowns, in which it is attached to these types of blanks, and this is attached to the spindle of the milling machine. Now you can very well see that a zirconia disc around about 98 millimeters diameter zirconia disc has been attached to the spindle of the milling machine. This is the spindle of the milling machine, wherein this is the working end of this as the burr, and when you start the milling process, it moves in all the direction. Moreover, the spindle also it moves. Now these movements movement of the milling machine, it is along the various axes. Now the milling machine are broadly they are being distinguished into various axes. Depending upon the various axes, they are being termed as the 3 axis, 4 axis, and 5 axis. Now once the construction data that has been produced by the software, it is converted into the milling strips, and the CAD software, that is computer aided designing processing, is being done, and you finally move into the milling device, right? So the 3 axis milling machine, in the with us we have the 5 axis milling machine. However, there are little shortcomings with 3 and 4 axis. In cases of 3 axis milling machine, you have it moves, that is the working end, it moves in 3 spatial direction, that is X, Y, and Z axis. Now in this 3 axis machine, the axis, that is divergence and convergence, is not possible, and therefore the minute details, that is the vertical displacement of your prosthesis, is not been milled properly, which has been overcome in case of 4 axis, that is along with the 3 spatial axis. The tension bridge for the component has been turned infinitely, and in various axes you are able to the record, as well as the spindle it moves, and you are able to get the final finished prosthesis. So you adjust the bridge construction in the 4 axis with a large vertical height displacement. A more addition to this is the 5th axis, in which the spindle also it rotates, right? So it's really wonderful that in the cases of 5 axis, the milling machine, it moves in all the directions, that is X, Y, Z, A and B. Now in the machine itself, you will be able to visualize the various movements along the axis that are taking place. So you can so the movements that has been that are being recorded in millimeters, and along each and every axis it will show how much amount of millimeters, whether in positive or negative, it will try to record it. So it's very nice to have a 5 axis milling machine, so as to record all the undercut areas, as well as the finer details, as well as to record the cusp fossas with the help of a 5 milling axis machine. Now the milling machines, they are of broadly of 2 variants, that is the dry processing and wet processing. Now, in cases of dry processing, wherein the zirconium oxide blanks, which are pre-sintered one, and they are very easy to melt. So when in cases of long span bridges, it's a minimal investment cost, and there is less wear of the burrs. So a burr can fabricate round about 30 to 40 units can be fabricated in a single disc. In a single 98 disc, you can go for fabrication round about 25 to 30 units of your fixed prosthesis. However, there is a disadvantage that it has a high shrinkage value. Now, these shrinkage values, the company will suggest along with the material, that how much amount of shrinkage is there. So accordingly, the percentage of shrinkage, you before you go for milling, you can feed it in the software, and that will help to prevent the shrinkage of the material. In cases of wet milling, you use mostly for your sintered blocks as well as for your glass ceramics, in which the mostly a diamond or a carbine cutter is used. And now, due to friction, there is generation of more amount of heat, especially in cases where you go for milling of metal as well as the glass ceramic materials. Now, in cases where you are going for metal or a glass ceramic materials, wherein the carbide burrs or your the burrs what you are using, it will produce more amount of heat, right? And to minimize this heat, you need to have copious irrigation. Now the machine in itself is provided with various coolants, and that will give you the wet processing. So that will again prevent the wear of your burr, as well as it will prevent liberation of heat during processing. This is the wet milling. Now, excuse me. This is the videographic image of the various milling that has been going on. So that was the wet milling, wherein continuous copious irrigation was of the coolant was going on, especially in cases where you go for the abutment milling, in cases where we fabricate the abutment with the help of titanium. So in that also more amount of heat generation is there, and it is supposed to be in a wet situation, and therefore the coolant is of prime importance to reduce the heat in these type of restorations. Now, the CAD/CAM can be used in for designing of various restorations, such as in cases where you have endogenous and exogenous discoloration, patients in whom you have the hypoplastic defects of the hard tissues. Then if you have improper contour size of the teeth and other malformations can be corrected with the help of CAD/CAM restoration. You can go for designing of onlays, inlays, as well as composites can also be fabricated. You can go for your correction of your smile designing. Now, here is an example where you have the missing 1-1 and 2-1. As well as you can clearly see the zenith of the lateral incisor. So along with the periodontal surgery, then we go for the fabrication of the provisional CAD/CAM made provisional restoration, that is PMMA, from the PMMA block, that is polymethyl methacrylate block, and we cemented for 3 weeks, corrected the zenith of the and give a proper a smile to the patient, and after 3 weeks we get it converted into a permanent restoration. Now the CAD/CAM, the complete denture prosthesis. So along with the CAD/CAM, with the help of a 3D printing, we are able to fabricate a complete denture, and I'm very much thankful for especially Mr. Vaishak from DensePro, Bangalore. We both have worked on the 3D printed complete denture prosthesis. Now, 3D is nothing but another form of a manufacturing approach, that is layer by layer, you go on adding it, and it is a form of additive manufacturing. Right. Now, here is a case wherein the lower dentition was hopeless of the patient, and we tried to give immediate prosthesis with the extraction of the remaining natural teeth. So immediate dentures, we all know that it has added advantage at the preservation of the masticatory and the phonetic function, as well as vertical dimension is preserved, bone preservation, and the surgical wound protection. So earlier we made the digital impressions with the help of the digital scanner. We performed the virtual extraction, and in the software we designed the prosthesis along with the anatomy, aesthetics, and phonetic parameters. We calculate the vertical dimension and transferred it with the help of a software to the computer. Now with the design, we finalize the project, and we select the tooth mold with minimum overjet and overbite, and we go for 3D printing of both the pink denture base as well as the denture teeth. And thus, after great finishing and polishing. Now, with the advent of CAD/CAM in complete denture prosthesis, you will be able to locate the various anatomical landmarks such as the transverse palatine folds, the incisive papilla, as well as you are able to design or to locate the minute details of where you want to give decrease the amount of the load. That also can be adjusted with the help of the software. We got milled the provisional dentures, and the 3D denture was ready. Now in the second appointment, we go on for extraction of all the hopeless teeth, and thus we gave the patient the immediate 3D denture. Then by routine instructions for maintenance of immediate with removal after 24 hours to be done, that you need to follow, and thus the 3D immediate denture was delivered to the patient. Now, other uses of CAD/CAM, that you can mill the implant abutment, you can go for implant retained overdenture bars, then you can go for cast partial dentures. Now, when you are going for implant abutment, now in cases of intraoral scanners, where you need to scan the implant abutment, the scan bodies are available with the manufacturers. Which provides you the implants, such as, for example, the Ostium, the BioHorizon. They have their own scan bodies. Now these scan bodies, they are placed in the implant body, right? Now that scan body will help you to capture the image with the help of your intraoral scanners, right? So various other restorations such as all ceramic, single crown, bridges, laminates, lunars can be fabricated. You can fabricate the cast partial, removal partial dentures, complete denture prosthesis. You can go for customized made implant abutments along with the crowns. Then various materials that are available in the market are for CAD/CAM materials, that are the titanium alloys, then chrome cobalt alloy, resin-based materials such as the PMMA for your provisional fabrication, as well as your composite resins, the PEEK material. All these are the resin-based material. Then silica-based, such as the monolithic inlays, onlays, veneers, crowns can be fabricated, infiltrated ceramics and oxide ceramics. So lithium disilicates, they are the ceramic blocks which has the high mechanical stability, and they can use for all ceramic, both anterior and posterior crown fabrication along with the copings. Where in cases the glass ceramic chair side, that is they are much more translucent and can be used as an aesthetic restoration, mostly for the veneers, and due to the glass content, they are etchable with hydrofluoric acid, and mostly in cases of fabrication of your veneers or aesthetic restoration, we go for a glass ceramic chairside fabrication. This is all regarding the various aspect of CAD/CAM, your intraoral scanners, your extraoral scanners, then your designing of the software, how to use it, the various milling and the materials, as well as what all prosthesis you can fabricate with the help of CAD/CAM. All has been been covered in this small duration time, and I'm very much thankful to conclude it once a new technology rolls over you, if you are not a part of a steamroller, you become the part of the road. So keeping in this mind, I hope that in a group we can have the purchase, and especially the colleges, they can have their own, and the dentist in itself in a group can purchase and go for the CAD/CAM restorations. I once again thank Dr. Shailendra Sahu sir, my friend Dr. Anurag, and all the organizing committee. I am really blessed and very much thankful for it, giving me this honor. Thanks a lot.
Thank you so much, sir. And so very well said that we are not, if we are not updated with the technology, we can lag behind, maybe a decade or more. So with that thought, now I would like to introduce today's second keynote speaker, Dr. Yogesh Ingole. Dr. Yogesh Ingole has done his BDS from BSPM Dental College, Nagpur, and MDS from Dr. D.Y. Patil Dental College, Pune. He is currently working as assistant professor at CDC Hospital, Nagpur. He has an experience of more than 11 years and has been working on CAD/CAM since last 5 years. He has also been working on designing on various research projects and theses related to CAD/CAM of the postgraduate students of the Central India. He has various publications to his credit, both at the national and international level. So we should all now get up for a live online demonstration on designing and fabrication of all ceramic CAD/CAM restoration by Yogesh sir. We welcome you, sir. Over to you, sir.
Thank you very much, Dr. Rucha. Am I audible?
Yes, you are audible, sir.
Thank you. First of all, a very thank you to the entire organizing team of Chhattisgarh Dental College and Research Institute, Rajnandgaon. I would like to again thank the board members, the dean, Dr. Suryavanshi ma'am, who is my teacher, Dr. Shailendra Sahu sir, my very good friends, Dr. Anurag Dani, Dr. Prashant, Dr. Rucha, and the entire organizing committee of the Department of Prosthodontics for giving us the opportunity to present this webinar on the CAD/CAM, a step towards the digital prosthodontics. Again, I would like to first thank Dr. Satyam Wankhede, who has given the base for, or given a good foundation regarding the overall view of the CAD/CAM, current scenario of the CAD/CAM in this dentistry. And starting with that, we will now have the demonstration of the patient scanning. Now this will include, we'll first do the intraoral scanning. As sir has told, there are two types of data acquisition systems, that is the intraoral as well as extraoral. So first we will be doing the intraoral scanning. Then we will transfer the data to the ExoCAD software. We'll fill up the data and we'll start with the designing into the ExoCAD software, how we fabricate or design the prosthesis. Then we'll go in for the nesting, and then we'll go for the milling purpose. The milling video you have already seen, but we will just in short, whatever best possible things can be shown during this small time interval, we'll try to complete as much work as possible. So with this, we have the, I'll just take the camera because it is there on the different computer. Okay. So just hold on a second. I would like to just remove the background for a while because the camera won't work.
You can go into the video setting here.
Yeah, I'm in the video settings.
Yes.
Just
And then virtual background, you select none.
yeah. Just yeah. So now this is the CAD imaging software in which patient details have been fed, and now the scanning will be seen on this screen. My colleague Dr. Satyan will be starting with the scanning. This is the intraoral scanner. CS3500 is and with this we will be doing the intraoral scanning. Now, there are different options of data acquisition for orthodontics, restoration, implant, and if you want to import data from somewhere, you can import it. So we'll be going it with the restoration part. Now, these are the arches, upper arch, lower arch, and finally the bite. Now, this is how you can see the teeth intraorally. And once the scanning begins, you will see the image which is being formed adjacent to this video. Now you can see on the left side, you can see the green clickings, and somewhere there is red. Red means the scanning is little faster. You need to be slower. It is not recorded properly. Green means it is recorded properly. Now this again you can see. Okay. The green too, that is the scanning is properly, the stitching is done properly. If you move directly from the second molar to the first premolar, it will show you red. But you have to go frame by frame, then it will start stitching properly. To record the occlusal, buccal, as well as the lingual aspects.
So, sir, you have started scanning from the posterior most and come to the anterior.
Yeah, whichever area we want to restore, like if we have to restore the molar, we will scan the adjacent teeth, that tooth and the adjacent teeth. So that is enough for the single tooth restoration. This is just for the demonstration purpose. So then, once these three teeth are scanned, we will use the upper arch. So, so you can scan the area which is required for a single tooth. You can scan the tooth in question as well as the adjacent teeth, one anterior and one posterior. That will be sufficient for uh, designing the prosthesis. This way, move it from the palatal, then go to the occlusal, and then go to the buccal aspect. You can start from anywhere, but make sure that don't jump from buccal to the palatal. We have to first record the buccal, then go to the occlusal, and then go to the palatal. Because it is on the stitching principle. It takes the image, the previous image, and then it stitches the new image. So this way, we will get both the images, and then this is for the buccal bite registration. Okay. This third is for the buccal bite. Now, these two scans we have got, the upper arch and the lower arch. Now ask the patient to chew, bite, and then you will get the bite acquisition will be obtained. As you move to all these three teeth, the bite will get recorded. Okay. So once we acquire the data, we'll proceed and save it. After the buccal bite acquisition, we will transfer the data to this computer, and from that, with the help of a pen drive, we will transfer it to another computer which is having the ExoCAD software for the designing part. I would like to share the screen. Are you able to see the project over here?
Yes, sir.
The screen, can you see? Yeah. Now this is the screen. Now here, this is the area from where we will be taking all the, filling up all the information about the patient. Now first, the client of the dentist. Here you can add the patient's name. The technician, again, as sir said, we are the ones who will be doing the clinical part as well as the laboratory part. Then the teeth that we are going to demonstrate, like for this, there are the job definition on the right side. We have got the number of teeth that we need to select. First, we will select the 3, 5, 3, 6, and 3, 7. We'll be fabricating, we'll be demonstrating the fabrication of a 3-unit fixed partial denture with the 3, 5, 3, 6, and 3, 7. Now click on the 3, 5 here. Can you see the tooth 3, 5 and copings, offset coping here?
Yes, all the details.
Yeah, all the details are there. So which kind of restoration, what kind of restoration we need to fabricate here, that we need to mark. Okay. Now here we want an anatomic crown over here. Okay, we can fabricate a coping also, offset coping, pressed crown, or even an anatomic pontic. Whatever it is, we can fabricate even an inlay, onlay, or a laminate. So here we have to use the Ceramil ZI, that is a zirconium that we'll be selecting the material for the fabrication. Here there are multiple options over here. So the pre-op model, scan gingiva separately, is it implant based, design of the gingiva, all these things can be done. Minimum width of the cement which is recommended is the recommended setting. You can increase it or decrease it according to your preferences. You can select the color, whatever color you have received, the color of the disc that you have received. If you have there is no mention of any color of the disc, you can write it as a no color, and then just click OK. That is the information that is for this particular crown, that is 3, 5. Similarly, we will have 3, 7, which will be again the anatomic crown. Again, the same settings, Ceramil ZI, the material won't change here, zirconium. Then we have 3, 6, that will be the anatomic pontic. Okay, a reduced pontic will come in case of copings. Okay, but now we have selected anatomic crown, so we'll have anatomic pontic in the position of 3, 6. Okay, and automatically the software connect these teeth, because this is a fixed partial denture that we'll be designing. That's why they have automatically connected these teeth. In individual crowns, it is your option to connect these teeth, or you can you may not have any connections also in individual crowns. So it is your preference, but in case of a fixed prosthesis, you have to connect these teeth because this is a pontic. Now you have to select 3, 8 and 3, 4 as the adjacent teeth. So here 3, 8 will be the adjacent tooth. Again, click to the adjacent tooth and write OK. Then 3, 4 will again be the adjacent tooth, likewise. And then as we have got upper and the lower, both the scannings we have done, so we'll have the antagonist as 2, 8 will be the antagonist, until 2, 4 we will have the antagonist. Okay. Now this way, on the right side, you will see the actions are not active yet. For this, we have to save the data. Now here, you can have a single model, you can have two models in occlusion, and a digital impression scan can also be done. Now, as we have done 2 models in occlusion, we will click here, and now this message has come that you have to click save to proceed. Now, after filling all the information over here regarding what kind of tooth, what kind of restoration we are using, what material we are using, which will be the pontic, what will be the adjacent teeth, and the antagonist teeth, we will now save all this information over here. And once we save it, you will see the right corner active. Now here there is Ceramil map, which is, as sir said, that is for the laboratory scanner. So we won't go to that. Ceramil match 2 is for the nesting. Ceramil motion is for the milling part. And then if you have some uploading, that can also be done. But now we will be moving to the Ceramil Mind, because this is the Mind software where we will be designing this entire prosthesis. So I click on the Ceramil Mind now. Now it will come as a Ceramil Mind. It is starting the Ceramil Mind suite. That is a software, ExoCAD software for the designing of the prosthesis. Now I'll just stop the screen sharing because this is a new program which is opening up. I'll again share the screen. Yeah. Now can you see this dialog box on the left?
Yes. Yes, we can.
Yeah. Now from here, whatever CAD/CAM cases that we have, the current scan that we have stored in the scanned computer, from that we will select the name of the patient. Now we'll take the mandibular first, because the mandibular arch will be fabricating the prosthesis, then the maxillary. Now this way, can you see the colored image of the
Yes.
arch? Yeah. Now this is the scanned image, not of this patient. This is the demo patient. Now this scanned area, we need to first set the axis. So set current axis, current view as axis. Now from where you want to place your prosthesis, you have to get the angulation so that you could be able to see the entire margin area. So you have to adjust the angulation. Now once it is set, you click it here, set the current view as the axis, and then proceed for the next. Now the next box which is coming, that is a wizard for the margin detection. Now you have to detect the margin, or you can manually draw the margin also. First, what they have denoted is tooth 3-7. Now for 3-7, we will correct or draw the margin. So you can click on here, correct or draw the margin. So you can zoom it, zoom out according to your preference, and then you can, with the right click of the mouse, you can rotate it and see the angulation which is preferred to you and start the margin line drawing. So from here, step by step, I am clicking the left portion of the mouse. With the left clicks, I am going throughout the entire margin area. So now you have got this margin. You can do corrections wherever you want, that the margin could be little farther from the tooth. You can take it. You want it nearer to the tooth, you can take it like that. So once you see it from the top, you should be able to visualize the entire margin. Once you're satisfied with the margin detection, you can proceed to the next. Okay, here is the next. Now the tooth mentioned here is 3-5. Now the software is telling us to draw the margin for tooth number 3-5. Now again, zoom, rotate the scan, and start drawing the margin for the tooth 3-5. Now here on the right side, just below this, there is an arrow denoting the level of the preparation. Just a millimeter down.
वाट पाहून आपण 24 तारखेला हो, पण आपण वाट पाहू नये तर उद्या तिथं चौकशी करू विचारायला
Somebody has unmuted. Mute.
So this way. Similarly, we'll again see it from the top. We should be able to visualize the entire margin. Wherever it is little away from the tooth, take it a little closer. And you can do the modifications manually in your margin where you want it, and then proceed to the next. So once we proceed to the next, you will see the insertion direction. Now, if there are major undercuts, you may tilt the tooth. You can see the, you can tilt the tooth and you will see the undercuts coming on the left side, on the right side. So the best possible path is this one where you have minimum undercuts. So this is actually a guide to us to do a better preparation without any undercuts. If there are any undercuts, you can detect it at this stage only, and you can go back to your preparation and correct the preparation and remove the undercuts. So it is a very good learning tool for us also, so that to have minimum undercuts in our preparation. So once this is fine, you can proceed for the next. Similarly, with the 3-5, it is showing where there are undercuts or not. If there are minor undercuts, you can slightly tilt the tooth and remove that undercut. Okay. So this way, we will proceed to the next. Now they have given us the option how much gap for the cement you require, that is 0.05 millimeters. You can increase or decrease depending on what kind of luting agent you're using. Then the margin from where you want this gap to start, that also you can customize according to your needs. And whatever by default for zirconium, they have already fed the value in the software, and you can customize it according to your choice also. You can increase 0.6, 0.7 or whatever recommended, you can stick to that value also. So once this this is done, you can proceed for the next, the cement thickness. After that, they will give the option of copy or mirror. If you have a full arch span, you can copy the contralateral side. You can mimic the entire prosthesis from the contralateral side, or if you have, there are different preset crown forms that are given by the software. You can use that also. So we'll proceed to the next, and now they have given this gross tooth placement you have to give. Okay. So this tooth form you have given. Now on the left side, you could see the antagonist. You can make it darker, can make it lighter, or you can entirely remove it also. Okay. Similarly, jaw scans are also there, cavities are also there. You can remove it or you can proceed. Now here, we remove the antagonist because we have to now position the tooth properly. Now these are the tooth forms that they have given. Here we can control it. Now you have to move it. This is the movement that you can do, the movement throughout. Okay, the entire tooth can be moved up, down, okay, or laterally. If you do it, click it over here, you can rotate the tooth. Okay, you can rotate it on whichever direction you want. And if you can see that size of the tooth is little lesser, you can click on the scale and you can increase or decrease the size. Whatever size you want, you can have it. And you can see the color which is changing. Once you are encroaching onto the occlusal space of the antagonist tooth, it is becoming pink. Okay, so pink means you are there are too much of high points. You need to reduce the tooth. Once I reduce the tooth, the pink portion is gone. Okay, the blue portion is acceptable, but once you go to the orange or the blue or the pink part, it is unacceptable, and you need to reduce the size. Okay. Now I'll just adjust it with the help of certain keys. The control key, you can rotate it with the shift, and the mouse you can increase it, or you can do it from here also. So I'll increase the size, I'll decrease it a little bit. I'll try to fit it in this place. Similarly, for the Pontic, we'll take it to its position. Now this orange portion that you can see into the fossa area, that is the minimum thickness that is there for the zirconia. That much of thickness is required. It won't go below that. So you have to, once this orange part comes, you cannot go beyond this. This much of thickness is there, will be there for the zirconium. Now for the Pontic also, we will take it little down. We will rotate it. And then for the 3/7, again we will slightly increase the size of the tooth so that it will cover the entire preparation. Now you could see too much of pink, so take it down to the arch. From the lingual aspect, that is the advantage of this entire scanning, that you can visualize it from the lingual aspect, you can reduce it, you can rotate it the way you want, and once it fits onto the prepared tooth, whatever minor corrections are there, we have one more step in which we can do these corrections. We can see it with the opposing arch, where we have can little increase the height of the Pontic. Then we can proceed the next. Now once we have grossly positioned the tooth, this is the free forming stage. The wizard is showing us free forming. We will remove the antagonist. We will see the entire restoration. Now here, it is the most important part. First, we have to adapt it. You can see free, anatomic, adapt, and attachments. So here we have to first adapt the Pontic. Now you can see here it is too much of extension. You can adapt to the gingiva first. Then occlusal, whatever high points are there, most of the high points would get removed. Now you can do it as cut intersections. Once you adjust the Pontic, after that you click on the occlusal and then proceed to the cut intersections. Now once I click on the cut intersections, most of the high points will get removed. Okay, only one is remaining, but that is again in a blue form, so no need to worry about it. Then the third correction is approximate. So whatever proximal contacts are there, if those are high, you can remove it by cut intersection. Okay, so the proximal contacts are also adjusted. Now after that, in the anatomic form, you can adjust the cusp height also according to the opposing tooth. You can increase or decrease the cusps. Now here, if I want little increase in the height of the cusp, can you appreciate the Pontic cusp? We can increase or decrease. I don't know whether it is visible or not. The Pontic cusp, we can increase or decrease.
Yes, it's visible.
Yeah, okay, good enough. So we can increase or decrease the cusp. Then once we increase the cusp, there is some high point that can be removed. So then we have tooth parts. You can individually some tooth parts, like if there is a little less contact over here, you can increase the contact by stretching the tooth a little bit. Can you appreciate this? That we can increase the contact on the premolar as well as on the molar. So with the tooth part, we can slightly extend the tooth. After that, again, we should adapt and correct the cut intersection so that whatever extra contacts are there, those will be reduced. Now, after this, there is a free form structure. You can add or you can remove the tooth structure. you can add, like here, there is a strength. Now, how much strength you want, that is the more amount of thickness will be added, and the brush size. For example, I'll increase the strength and I'll increase the brush size. You can see this is the brush size. This is the green colored area. It is the brush size. Dark greens means it will reduce more chunk of the tooth structure. So it is always a good practice to have a lesser brush size and a moderate strength for the better correction. So now you can zoom in and you can see the darkness is reduced and you can minor corrections can be done. Now we are at the add stage. We can add here, the material is adding. You can see from blue it is turning to pink. So you can undo it or you can smooth or flatten it. Okay, there is always an option to undo whatever things you have done. You can undo it, or after smooth or flatten, that means you can reduce. Okay, so here we can reduce the thickness of the zirconium. Again, here also we can reduce whatever high points. We have increased the height of the cusp, but it is slightly coming in the occlusion. So you can reduce that much portion which is coming into the occlusion. You can step by step reduce it. Okay. So this way. Then Pontic, you don't want so much of encroachment. You can increase the strength, slightly brush size, and you can see the dark green structure. So more chunk of Pontic area that is getting reduced. So whether you want to give a sanitary Pontic, you want to give a modified ridge lap, that can be done in this stage. You can reduce the Pontic of the lingual aspect. You can see you want a very light contact, you can have a very light contact or a bullet type of a Pontic. That can be done from the buccal aspect. You don't want so much of encroachment onto the gingiva. You can reduce it according to your wish and the kind of area that you are dealing with. Now, we will go for the individual tooth correction. Now, once this is done, we will again reduce the strength, try to reduce this area, but there is some high point is there. But as sir also explained, as it is in a blue color, it is little acceptable. But once it is pink or orange, it should not be done. Now I'll be smoothening the minor grooves are there, which are whatever sharp angles are there, we can smoothen it. Now you can undo this procedure, this step. Yeah. Now another advantage of using this CAD cam is you can smoothen individual tooth from the proximal aspects also. Now here there are multiple teeth. You can remove the jaw scan. You can have your only prosthesis part. So you can smoothen from the occlusal aspect. Now here you can see here the antagonist, and you can scale the adjacents also. Now here you can see the contacts of the adjacents. There are very light contacts, so no problem in this, and you can smoothen it from the proximal aspects. You can, if you want to see the distal aspect of the Pontic, you can remove 3-7 and you can see this also. Okay. Base of the Pontic. This way, you can see the base of the Pontic. You can smoothen it. So these are the fine corrections that we can do. Now again, there is some high point. You can undo this step and smoothen the other areas this way. Now we can see it with the adjacent teeth as well as with the antagonist teeth. Okay, you can see it from the lingual aspect, you can see it from the buccal aspect. If you want more reduction over here, you can give the contour. Now this way, once we are satisfied with the prosthesis, we can proceed to the next. Now we have to design the connectors. As is a fixed prosthesis, the connector design is also important. By default, they have given a circular shape. You can give squarish shape, oval shape, or a plus a pattern can also be given to the connector. Now the connector thickness we can see by the free form. Now here you can see this is the shape and this is the free. Once we click on the free, you can see that most of the connector, almost all the connector, it is in a blue. That is, it means it is very thick. That is what we want. You can have the best amount of thickness. You can even increase or decrease the extension of the connector. Like I'm doing it over here. If you want to make the connector go little gingivally, you can extend it little gingivally also this way, or you are satisfied with this, you can straight away undo it. Okay? You can increase the thickness, you can increase the extension onto which tooth you want, how much amount of connector, you can customize it. Similarly, on the other side also, you can increase, but entirely we have a very thick connector, so that is what it is desired in the posterior restoration where the occlusal forces are high. In anteriors, as I said, yellow, orange can be done, but because there are low occlusal forces, but pink is too thin, we should avoid giving a thin connector. So once we adjust the connector, you have different dimensions of connectors over here, and then we'll proceed to the next part. Now, even in this stage, our prosthesis is ready for the fabrication, but if we want to do certain corrections in this stage also, we have this expert mode on the right side. Okay, so here the expert mode wizard will come. So you click on the tooth on which you want to do corrections. Again, go to the free form. That is a free forming procedure, and you can smoothen the area which you want to smoothen, or undo it if you don't want to. So any kind of corrections can be done at this stage also. You can smoothen the connectors also. You can click on the once you finish, okay it. You click on the other tooth also, you can do similarly with the free form. You can do the correction on other tooth also. Once you are satisfied with the corrections, you can proceed. So again, click on this wizard and you are back to the stage of final prosthesis. So save all these data. Now you have the option that I'm done, proceed to production, or again you want to do free form corrections, can be done, or you can again go back to the expert mode. So we can proceed to the production. Okay. So where we will do the nesting part. So we'll click on to proceed to production. So there is, you can see the Ceramil Match 2. That is a software for the nesting of this restoration. Are you able to see Ceramil Match 2?
Yes, sir.
Okay. Just tell me whether you can see the next screen, because here the screen sharing stops. Can you
Yes.
see the searching machines?
Yes, it is open.
It is open. Okay. Now this is the nesting part. This is the angulation with which we are moving, and there the nesting, it will take a little while to load the material that we are going to have for this restoration. It's telling the height of the construction, that is 11.39 millimeters is the entire height of this restoration. So accordingly, you have to select the disc size, that is at least 14 or 16 millimeters. There are different size restoration. So you can add the blank over here. Now we have this 98.16, that is zirconium blank. Yeah. So here you have to enter the lot number. And this shrinkage code, that is very, very important. What sir has told in the presentation, that the shrinkage code is very, very important, which is in this material, it is 7.32. It depends on the material to material. The code is written on on the disc itself, and that you have to select. So you can, after doing the settings, you can use the blank. So now you will get the blank. Okay. Can you see this blank?
Yes.
Yeah. Now this is the frame. This is the outer frame, which is attached to the milling machine. Now you can adjust your restoration. You can rotate it, you can move it. And these are the connectors. Now first, make sure that it won't go out of the margin. Okay, it will show as a red. So be within the margin of the disc. You've selected a corner. You can see it 360 degrees. Now here you can again zoom in, zoom out. If you have difficulty with the frame, you can remove the frame. Here there is show frame. You can click it over here. You can remove the frame, and you can see it from the other side also. So once you're done with the position of the prosthesis, you can, so this is the position reconstruction. Now here you can see the change connector. Here you can change the connector. Okay, so this is the connector. Now here you can increase the connector diameter, or you can decrease it. If we want a thicker connector, you can select as, for example, 2.5 millimeters. You click on the connector, the width will be increased. Again, you click on the connector, the width will be increased. If you want to add some more connectors, you can just click on the area, left click with your mouse, and you can stretch it like this. You will add one more connector over here. If you don't want the connector, you can remove it also. Remove support pin, that is the option over here. So you can remove this connector also. You can add or remove, whatever you want. Then cut off the connector is another option. How much connector you need the machine to cut, that you can increase or decrease. You want 80% of connector to be cut, that will be easier for us to cut the sprue. So while removing the process also, it is little easier when you cut off the connectors. So machine will do 80% of the work for you, and the 20% work will be done manually by us. So we can cut off the connectors, and now here we can see that the connector should be here in the center. So as it is near the gingival margin, you can move it upwards. Similarly, on the buckle side, you can move the connectors this way. Will do. So once it is done, you can see from all the aspects. On the right side at the bottom, you could see different views, whether it is residing properly inside the disc diameter or not, and the disc thickness or not, that is also seen. Well, sometimes in the long span bridges, there is some problem with the angulation. You can change the angulation because sometimes within the small diameter, within the small thickness of the disc, a long span bridge may not get accommodated there. Yeah. In that case, you will, now there is a lock inclination and there is show axis. You can click on this, so the axes are now not locked. You can reset the axis by moving it like this. Okay, you can move the bridge like this so that you can accommodate a long span bridge which is not getting accommodated in the disc. Okay. In this case, being a 3-unit bridge, you can easily accommodate it. So we may not go for it, but in some cases when there is a 6-unit or 7-unit fixed prosthesis, there you might have to use this lock inclination. You have to disable the lock inclination and you can move the bridge like this. So again, we'll lock the inclination, and now in doing so, we have gone little out of the disc space. So again, we will bring the prosthesis back inside this way, rotate it. So this way we can proceed for the production. Once the nesting is done, we are ready to proceed for the production, and the milling will go on. Now we need to proceed to the production. Now there is something called a start calculation. It will start calculating this data. Can you see the start calculation path? That is the tool path calculation. So whatever design data that we have done, it will be calculated and it will be transferred to the milling machine. So till this portion, the CAD procedure is done. That is the computer aided designing that we have done. Now we are proceeding to the CAM part. That is the computer aided milling or the machining part. Now the data is getting transferred. The entire designing part, it is getting transferred to the milling machine, which is a 5-axis milling machine. That is a Ceramil Motion 2. We have a circular blank holder that is of 98 millimeters diameter. This is the blank holder. Now this portion, it is attached to the milling machine and it will rotate according in the 5-axis, and it will mill the entire processes in all its dimensions in the 5-axis, whether there are grooves, cusps, whatever elevations, depressions are there, that will get milled in this 5-axis milling machine. Now it is almost done, the transferred part. Now they are telling us to start the milling machine. We will start the milling machine, or you have any correction still required, you can continue with the CAM software. So we'll be starting with the milling machine. Now, can you see this screen? Which machine would you like to use? Is it visible on the screen?
No, sir.
No. Okay. I'll again stop screen sharing and restart it. Yeah. Can you see now? Home position not known. It is written.
Which machine would you like to use?
Yes. Which machine would you like to use? Now it is connecting to the machine. So this is the ceramil motion. Here, the home position is not known to the machine, so it will adjust it to the home position. It is a idle. This is the position from where the machine will start milling. Now this is the different sets. You can see the tool operation of T1, T2, and T3. That is a tool operation. Once it reaches the once it crosses the orange part and reaches the red part, it is advisable to change the tool. Then the blank holder, it is shown. We are using the 98 millimeters blank holder for the zirconium. This is the maintenance. The machine will tell us for the periodic maintenance which is to be done or not. Now here you could see the data, the transfer data, and you can see all the information on this right side, at what time you have done this milling, and then you can transfer the files. Now from here, the file will get transferred. Now there are different tools, that is T1, T2, T3. Now for zirconium, the T1, that is, it is a 2.5 millimeters carbide burr. For T2, it is a 1.1 millimeter, and for T3, it is 0.6 millimeters. Similarly, there is another one that is for wet milling. Wet milling, we have T1, which is 1.8 millimeters, T2 is 1.4 millimeters, and T3 is a 1 millimeter diamond burr. So wet milling is for the glass ceramics, and dry milling, we are doing it for the zirconia wax. Okay. So once we do it, we will click OK. And now the data is getting transferred to the milling machine. You can start the program automatically after the transfer. So once all this information has been given to the machine, you can start the program, and you will have how much time which is remaining, how much time it will take for the milling of this entire process. All will be shown over here. So this way, you can, over here, you can see the milling machine. Are you able to see the milling?
Yes.
We have intentionally kept it blank so that you could see the.
Sir, it's not full screen.
Okay.
Can you please make it full?
Okay. First, before that, you can see the program which is running, and the effective time is 36 seconds. Yeah. The effective time is 41 seconds, and the remaining time is 35 minutes. Okay. Now here, you can see the different axes: x-axis, y-axis, z-axis, A and B, the angulations in degrees, and x, y, z in millimeters. You can see the position of the spindle of the burr. Can you appreciate this?
Yes.
At what angulation, in which axis it is moving, how much it is moving. Right now it is not moving in A and B, that's why it is showing 0 degrees, but once it starts moving, it will show the values. Now the time, approximately 35 minutes, it will require to scan the entire prosthesis. Now I'll stop the screen sharing, and
No.
I'll now show you the milling machine. This is the Ceramil Motion 2 milling machine that we are having. And for demonstration purpose, we have seen how the burr is moving. This is the 98mm blank holder in which the zirconium disc is inserted. And are you able to see the spindle which is moving? The spindle which is moving. On the left side of your screen, see the spindle moving. Just for the demonstration purpose, we have kept the area blank so that the spindle movement should be visible. So this is the Ceramil Motion 2 milling machine that is scanning, that is the machining part. Okay. Now, if we have little time left, we can show you the laboratory scanning also. A small part will be there for the lab scanner. Do we have 5 minutes?
Yes. Yes, sir.
Okay. This is the laboratory scanner, that is the Ceramil MAP 400. This is the cast. This is a prepared tooth which we have already kept over here, and we will start the scanning of it. Now, before it starts, I'll just tell you about the centering part. Now, once this milling of the zirconium is done, we will do the entire milling is done. After that, we will cut the screws and we will put this entire processes in the centering furnace. Now, this is to be centered for a single unit. We have a P1 cycle, which is of about approximately 8 hours. So overnight, we have to center it. For a single unit, we have a P1 cycle. For 3-unit fixed processes, we have a P2 cycle, which is approximately 6 hours. We have full arch. If there are full arch copings, we have P3 cycle for full arch copings. And for a monolithic solid crowns, we have P4 cycle, which is approximately 12 hours. So it takes around a day for a zirconium crown to be built. But for a glass ceramic, it can be done in 1 to 1.5 hours because those blocks are pre-sintered blocks. Now again, I would like to share the screen. Again, you need to feed the information, or you can have a new patient over here. You can click to the new. Feed the information. Now we have prepared tooth 1-3. You can guess a crown. Again, the same information need to be filled. 1, 2 will be the class color. 1, 4 will be the adjacent tooth. If you have a single arch, you can keep it as it is, or if you have both the arches, you can click the other antagonist also. If you have one stone model, you can click to the save. Once it is saved, you have the right side active. You can select mind, map, but as we have not done the scanning, intraoral scanning, if you do intraoral scanning, you can do the mind like we have done for the previous case. But here we don't have the patient with us. We have the cast of the patient. So you can go for the, or you can have impression. You can scan the impression or scan the cast. So we'll click on the Ceramil map. So are you able to see the Ceramil map coming up? Are you able to see the scan written over here?
So which side?
Upper jaw is written.
No, sir.
Okay, I'll again stop the screen sharing and restart it. Because as the program is changing, no, the screen sharing needs to be again updated. Now, can you see upper jaw?
Yes. Now we can see.
Yeah. So there is a select plate. The 1 number plate we have kept. We'll start the 2D scan. So the scanning, it is now giving us this bar. Can you see this? We have to select the area we are concerned about. The tooth in question and the adjacent teeth. Then we click on the continue. So it will start scanning. Are you able to see the scanned image?
Yes, sir.
Of the upper cast? Okay. Good. You can continue or you can abort the preparation scanning. Here it is refining the scan, or afterwards also manually we can refine the scan. If you have die cutting done, you can remove that portion and you can do the proximal area scanning also. Now here you can see that some portions are not properly scanned. You can add the scans. You can go over here and you can rescan those particular areas. So whichever areas are not coming properly, you can always rescan them. would again like to show you the camera also, show you on the camera the machine, how it is working. Are you able to see the lights inside the scanner?
Yes, we can. Linking.
Okay. Again, one more time.
Okay. Yeah.
So there are 3 cameras inside the laboratory scanner. It is scanning this cast from various angulations. So this way, yes. This is the Ceramil Map 400, which is an extraoral scanner on which scan. And after that, we can finalize the project. And from this portion, we can again go back to the Ceramil Mind, the way we have done it after the intraoral scanning. We'll go to the Ceramil Mind, design the processes the same way we have done it for the 3-unit processes. Only the data acquisition is different. In the earlier case, we have scanned the patient with the intraoral scanner and designed the processes. In this, we have done the scanning of the cast. Similarly, we can do the scanning of the impressions also, and then in the Mind software, we can go for the designing part and then milling in the Ceramil Motion 2 milling machine. So that way, we would fabricate the entire processes. So as you have seen the disk, so this is the one more holder, blank holder, which is, these are the milled blocks, and this is the block to be milled, which is a pre-centered one. This is the glass ceramic block on which we can mill it, and within say about 20 to 25 minutes, 15 minutes will take for, the 10 minutes will take for the scanning, 15 to 20 minutes it will take for the designing part, and the milling part will take another say about 20 minutes. So within an hour or 1.5 hours, we can deliver the crown, the ceramic crown, the glass ceramic crown to the patient. But for the zirconia, of course, you will have to wait overnight for the sintering purpose. So yeah, if you have a pre-sintered zirconium, you can deliver the crown within 1 or 1.5 hours to the patient. So that is all about, means that is just the tip of the iceberg that we could tell you within this time period. There are many things which we are also learning, and many things need to be learned, but this is just a basic thing what we could show you. I hope we could solve your doubts, and if you have the students also have any doubt of the faculties, they are free to questions also.
Okay,
thank you very much.
Thank you so much, sir. It was such an insightful and comprehensive demonstration of the entire complicated process of fabrication of a prosthesis by CAD/CAM. If I will give few seconds to minute for any students or staff member to raise any doubts or queries they have. Okay. All right, maybe we can gather all the questions in our platform, and by that time okay, so let's continue with the program. And now I would like to request our beloved Dean Ma'am, Dr. Hema Suryavanshi, to say a few inspiring words to all the attendees of the program. Over to you, ma'am. Yeah. Thank you.
Thank you, Dr. Satyam Van and Mr. Yogesh Ingole.
Thank you, ma'am.
Efficient and very knowledgeful sharing, and we are really grateful to you.
Thank you.
Whatever you explained in this less time. From both of you, Dr. Satyam and Dr. Yogesh Ingole, both of you have presented it very nicely. And thanks again for the of your especially your cat. So, what I would like to tell you that I have done my BDS in the year 91, like house job, and that time we do it on triple arm. Only triple arm was there, and
Exactly.
and only impression compound and
Yes, sir.
materials were there. Right?
Yes.
So, moment for me, it's very nostalgic for me to see the GDC Nagpur Prostho department coming to a long way and having the best of the equipments and every having the best teachers, I would say. So it's a very proud moment for me. And thank you once again. And thanks for your really, like, I was zero in CAD-CAM, but now my concepts of, I know something rather than nothing about CAD-CAM now. And Dr. Yogesh, you have shown the hands-on very efficiently. Your patience is like,
Thank you. Thank you, ma'am. Thank you, ma'am. It's all are your blessings, ma'am. Thank you.
thank you to once again to both of you, and
Thank
wish
you,
you
ma'am.
all the best.
Thanks.
And you will keep on going ahead in life, and we will be inviting you once again. We will be
Definitely.
Yes.
once again to share your knowledge. Please be us, accompanied with us, be with us. Thank you.
Thank you.
Sure, sure, ma'am.
Thanks.
Thank you.
Sure.
Thank you, ma'am.
Over to you, Rucha.
Thank you so much, ma'am, for this time. Now, the purpose of this webinar was to explore digital dentistry, and the best known digital dentistry part is, of course, CAD-CAM. And the purpose was intended to provide a practical view of digital dentistry, a stimulus for great adaptation of CAD-CAM, and emphasis on faster integration of it. So let us now, me representing the Department of Prosthodontics under the direction and supervision of Head of the Department, Dr. Shailendra Sahu, facilitate Dr. Satyam Vankere with a certificate of appreciation from the department.
Thank you.
Thank you so much.
Thanks. Thanks a lot.
And of course, as ma'am said, Dr. Yogesh, sir, we appreciate your effort and explain slightly and in detail the entire process. Thank you so much, sir.
Thank you. Thank you very much.
Of appreciation from our department under the supervision of our head.
Thank you.
Thank you, sir. And for the rest, all participants and attendees of this webinar, we will be sending the feedback form to fill it and a certification of participation to all of you through our WhatsApp group and individually. So let me now conclude this with saying few words and of course inviting Dr. Anurag Gandhi sir for the vote of thanks. Dani sir he who is the professor of the department in our department. And in the end, I would just say that the future of dentistry is now, and we are very lucky to be in this era of dentistry, and we should all cope up with it and be a part of the digitalization process. Over to you.
Thank you, Dr. Ucha. Honorable President, Mr. N.C. Parak sir, Vice President, Mr. Sudhin Buddha sir, Secretary, Mr. Sanjay Gulsha sir, and all the distinguished directors of CDCRI, respected Dean Madam, Dr. Hema Shurivanshi Madam, our guest speakers, Dr. Satyam Wankhede sir, Dr. Yogesh Ingole, and all the distinguished faculty members, dear delegates, ladies and gentlemen. It's my privilege to have been asked to propose a vote of thanks on this auspicious occasion. I, Dr. Anurag Dani, on behalf of Department of Prosthodontics and entire organizing team, and on my own behalf, extend a very heartily vote of thanks to all for gracing this occasion. I extend a deep sense of appreciation and gratitude towards Dr. Satyam Wankhede sir for accepting our invitation and gracing the occasion with his presence and giving an excellent coverage and application on the topic of CAD/CAM step towards digital prosthodontics. Thank you, sir. We are very grateful to Dr. Yogesh Ingole, course coordinator for this course, CAD/CAM towards digital prosthodontics, for making sure this program progresses smoothly with displaying practical application about this current trending topic in dentistry, for coordinating everything so very well. Thank you, Dr. Yogesh.
Thank you.
I wish to express sincere thanks towards our patrons, President Mr. N.C. Parakh sir, Vice President Mr. Sudhir Buddhan sir, Secretary Mr. Sanjay Golcha sir, and entire respected management in board of the college for ever being so encouraging and supporting in all our occasions. Thank you very much, sir. I am very grateful to respected Dean Dr. Hema Suryavanshi Madam for her guidance and enormous cooperation for organizing this program. Thank you, Madam. I would like to express our sincere thanks to all the heads of department and distinguished faculty members for gracing the occasion with their presence. I convey my heartfelt thanks to each and every participants who have attended this program. Like said, no events can be successful without people who dedicated their resources and time to make sure everything is faultless. So we have been fortunate enough to be backed by a team of very motivated and dedicated colleagues who know their job and are result oriented. My sincere thanks to organizing team, Dr. Shailendra Sahu sir, Dr. Rucha, Dr. Akansha, Dr. Nehar, Dr. Manupreet, Dr. Poonam, Dr. Saurabh, Dr. Prashant Kothari, Dr. Prashant Dubey, Dr. Ankita Bohra, Dr. Poonam Agrawal, and all the postgraduate students. They all work smoothly shoulder to shoulder to make this program successful. I once again thanks to our guest speakers, management and dean of this institution, entire organizing team and all the distinguished assemblies for this webinar. Their august presence valued on this occasion. Before concluding, I would like to apologize for any mistakes or mismanagement if any. Comments, suggestions and even complaints are most welcome. Thank you all. Thank you very much.
Thank you so much, sir. Thank you all the attendees and thank you everyone to be a part of this program. We will be ending. Thank you so much.
Thank you. Thank you all.
Thank you. Thank you, sir. Thank you.
Thank you.